This week, we will start with the second cycle, which is the synthesis of benzocaine. What is benzocaine? Actually, benzocaine is an ester of para-aminobenzoic acid and is used as a local anesthetic and also as sunblock. If you look at the general scheme of benzocaine synthesis, you can see that it's composed of 4 steps. The first one is called acetylation, where you are going to add acetyl group to the amine group in the para-toluidine in order to synthesize the N-acetyltoluidine. The second step, which is called oxidation, where you are going to use KMNO4 as an oxidizing agent in order to oxidize the methyl group to carboxyl group to produce p-acetamidobenzoic acid. The third step, which is acid hydrolysis, where you are going to use an acid in order to hydrolyze the acetyl group that you added before to get the para-aminobenzoic acid. And the last step, which is esterification or Fischer esterification, in order to add an ester and finally to get your final product, which is benzocaine. Starting from step 1, which is the synthesis of N-acetyltoluidine. This step is called acetylation step, where you are going to add acetyl group. But for what? You will start with a compound called para-toluidine. Caution, para-toluidine is toxic by inhalation and upon contact with your skin. Another caution, it's also carcinogenic. So make sure to deal with it cautiously. In this step, you are going to react the para-toluidine with acetic anhydride. You will use a buffer system consisting from sodium acetate and acetic acid, and the final product is an acetyl para-toluidine. So, in this step, you are going to acetylate the amine group in the para-toluidine as an initial step. But why do we need this step? Why do we need acetylation? Actually, the reason for acetylating the amine in the initial step is to protect the amine group during the second step, which is the permanganate oxidation that will come later. If the oxidation of this methyl group to the corresponding carboxyl group were carried out directly with para-toluidine, actually the highly reactive amine group would also be oxidized in the reaction. So in order to prevent this undesired oxidation, we will use a protective group. What is a protective group? Actually, it's a functional group that is added during the course of the reaction, okay? In order to protect this molecule from undesired reaction. Make sure that this protective group should be easily added and easily removed. Okay. As a side product of this reaction, acetic acid is going to be formed. Now, this acetic acid will cause the para-toluidine to be protonated. And we don't want this to happen because if the para-toluidine was protonated, actually it will become non-nucleophilic. So we will use a buffer system of acetic acid and sodium acetate in order to keep the pH of the reaction high enough and to ensure that the para-toluidine is not completely protonated by this acetic acid that is formed as a side product. So in this step, you will start with para-toluidine and end up with an acetyl para-toluidine or the p-acetotoluidide. Start the first step of p-acetotoluidide with the grinding of p-acetoluidide and weigh around 2.20 grams under a fume hood. In a 100 ml Erlenmeyer flask, add 2.20 grams of p-acetoluidide, then add 50 ml of water, and 1.7 ml of concentrated hydrochloric acid. Make sure to add the hydrochloric acid under a fume hood. Shake till the p-acetoluidide dissolved. Now we will start adding the acetic anhydride. Now add 2.7 ml of acetic anhydride. Swirl the contents to dissolve the anhydride. Now add at once the sodium acetate solution that is previously prepared. Keep mixing the reactants thoroughly by swirling. Cool the reaction mixture in ice bath for 3 minutes. Now, start collecting your product using suction filtration. Now, let's go for the second step, which is the synthesis of p-acetamidobenzoic acid. In this step, we will start the p-acetotoluidide and end up with the p-acetamidobenzoic acid. This step is the oxidation step. It's the oxidation of the methyl group to its corresponding carboxyl group using KMNO4 as an oxidizing agent. Now, in this reaction, the violet solution of permanganate is going to be converted to a brown precipitate, which is composed of manganese dioxide. From this oxidation reaction, hydroxide ion is going to be produced. And this hydroxide ion and the excessive basic conditions that is going to be resulted is going to lead to the hydrolysis of the protective acetyl group. So we are going to add a small amount of magnesium sulfate in order to serve as a buffer. That will prevent the solution from becoming excessively basic from that hydroxide ion. Now, actually from this reaction, our product is not going to be the carboxylic acid, but rather the salt, the p-acetamidobenzoate. Okay? Now, in order to precipitate this product, we will acidify the reaction mixture. This acidification is going to convert the benzoate to benzoic acid that is going to precipitate from the solution, where you can collect it after cooling. Collect the whole product and put it in a 500 ml Erlenmeyer flask. Now, add 5 grams of magnesium sulfate hydrate crystals, and then add 125 ml of water. Shake the mixture. Swirl the acetotoluidine solution vigorously. Now, start preparing a solution of 5.1 potassium permanganate and 30 ml of water. Put it in the hot plate and start heating till boiling. Make sure that your permanganate mixture is not boiling for more than 1 minute. If so, remove it from hot plate, put it in your bench for 1 minute, and then return it back for hot plate in order to avoid evaporation of water and then precipitation of permanganate. Swirl the acetotoluidine solution vigorously, and now start adding the hot permanganate solution. Make sure to take it from the crystals in the lower part of your beaker, not from the solution in the upper part. Start adding the solution over a period of about 30 minutes. Prepare your filtration setup. Add some water to your flask and put it in the hot plate in order to start filtration. After 30 minutes, we will start filtration. Start filtration. Now take off your filtrate, put it in ice bath for about 3 minutes. Make sure that your filtrate is cold enough and start adding 20% aqueous H2SO4 to make the pH around 3. Start stirring using a glass rod in order to get your product. Check pH using litmus paper. Okay. Now start filtration using فخن الفرد. Make sure to rinse the flask using cold water and continue filtration. Your product is ready. Take it off, put it on a filter paper to keep it dry for the next lap.